right, time for another physics.com, debatephysics.com also. But nobody debates very well. Let's just put it that way. Certainly no video, counter-video, argument, counter-argument kind of thing can be obliged, forced, in any way manifested. So there is this obvious problem, in my opinion, kind of obvious. That's why I'm talking about it for 2 years. It's duality, paradoxical nonsense. You can't have two kinds of energy. So they have this kinetic energy theory, which says energy is something called mv squared, and it's a half in front of it, not terribly relevant. But anyway, and I would argue with the classical Newtonian style understanding, Descartes, Galileo, of quantity of motion, or traditional momentum. And I would argue that there's not a single example of anything that takes place in the real world where they could cite where momentum fails to get a reasonable answer. So just following the momentum and understanding that momentum is a quantity, and just saying that you can't destroy the quantity, and that whatever goes into something in terms of the quantity of momentum, that quantity, that amount, 50, doesn't matter what direction, that has to come out of the event. That there's no other way it can happen. And obviously two things going 50 in the same direction, momentum-wise, they don't exchange too often if they're the same size, but you could have a very small object with a 50 momentum and a very big object with a 50 momentum, okay? And the small object will be going much faster, so it'll hit the bigger object, and all it's going to do is reverse the positions. Basically, the small object will be going the speed of the big thing, and the big thing will be going at the added speed of being hit by the smaller thing. It'll take its momentum and convert it over its mass and increase its speed by some percentage. All right, but you'll have the same total momentum. So you always have the same total momentum. So whether they crash into each other like this and bounce off of each other elastically. Now, if they hit each other and crush, inelastic, then obviously all the deformation, the bending, the crushing, the sound, the vibrations, all of this heat, then that would be where the energy goes, and you won't see it. So in the examples we're discussing, it's purely elastic collisions we're examining, because it's really easy to see the energy go in and the energy come out. Relatively easy, let's just say. As long as people aren't distorting and perverting the evidence, it can be seen pretty much. All right, so there's 2 years of this. 2 years explaining how. All right, just explain to me how levers don't conserve momentum. Just explain to me how that can be a possibility and you don't make free energy. Because obviously I can keep putting heavy things on one side of the lever close to the fulcrum and push light things fast on the extremity of the lever and create extra, because of the squared velocity, energy. Free energy. So, the lever, one of the simplest, oldest machines known to man, blows the idea up pretty much. I mean, it's a pretty catastrophic rational failure. You can't rationally understand how levers can't conserve momentum, and you certainly can't understand how they can conserve kinetic energy, because they can't, because they conserve momentum. All right. But anyway, so here we are 2 years later, arguing something that frankly shouldn't be arguable just because the duality exists. I'm saying there is absolutely no experiment you can look at superficially all right, and not understand momentum as being the mechanism. And especially the obvious ones, Newton's cradles. They just show it all over the place. The very idea they're claiming, it's just so anti-reasonable. Okay, it's so obnoxious to reason. So we know this is what goes in: 100 in, 100 out. 100 in, 100 out. 100 in, 100 out. It doesn't matter what direction it's going in. Bullshit. Doesn't mean anything. And their theory is that if I glued these three together, all right, I hit it, okay, that all three of these fly off with 150, not 100. They have 150, and this one goes back the other way with 50. So now I have 200 momentums in the universe. And then they collide. The 150 hits the 50, and miraculously, in my opinion, they have this idea that, now only the 100 pops out. The 50s cancel, and all you get is this 100 back. So you had 200 in, and you get 100 out. And they say that makes sense to them. Now, obviously, the Newton cradle says, no, it doesn't happen. Okay. You hit the 3 mass with the 1 mass, and what you're going to get is half the energy. No, 60% of the energy goes one way, and 40% comes back the other way. Momentum. And then when the two collide, the 60 into the 40, the whole 100 leaves, because of the heavy object is more willing to give its energy away because it's going the slower speed, and the lighter object, it's easy to make it go the slower speed. It's hard for a fast little thing to make a big thing go fast. It can't do that. But it's easy for a big thing going slow to make a little thing go fast. All right. So from that perspective, we'll read a comment and then do the same old crap. I'll go to an Ian Gosling video where, he's, he, at least he hasn't titled it something called Proof, but the titles are all shit. And I think he retitled one of the older videos, actually. But anyway, it doesn't matter. It's just another claim that somehow he's showing us the truth. And no, he's just, again, confusing, distorting, perverting reality, okay, on a mission to deceive. And that's all he's about, is deception. All right, about the collisions between 1 million and 1,050,000 momentums. Yes, so just tell me your prediction. So their theory says pretty much it's a done deal. I have 500 coming this way. I have 550 coming this way. They hit each other. The 500s cancel, and all I get is 50 out. Now, we know that doesn't happen, right? We know if 500 and 500 go in, I'm going to get 500. I'm going to get 1,000 out. I'm going to get both. The total amount is coming out. I'm not going to have any of this subtraction crap. We know from a Newton's cradle, that's just an absolute fact, that if they're the same mass, and changing the mass really can't change anything. And, it's a known fact that, these two hit each other. It almost hits each other. It's a little hard from this perspective to do this properly. Yeah, well, they bang into each other, and the energy keeps coming out. They hit, they bounce, they hit, they bounce. That's what happens. You can't destroy momentum. All right, for some reason you are making the assumption that according to the theory, yes, according to your statement, that somehow Newton and Huygens defined this law, this subtraction law. And it's not a subtraction law in the first place, but in the second place, you have to live with your own statements. What you've said is the stated truth of it, how it works. The difference in the momentums must be in one object after the collision while the other one stops. Right, and that will happen as long as one of the objects is heavier than the lighter object. So yeah, I have no idea why you are making that assumption, because it's a direct statement you've made in your previous comments that this is the law that Huygens established. And it's not a law, and it isn't the truth. The theory says nothing like that. So it's just, you can't argue with people this dishonest. It's clearly what you're stating is the theory. This is how it works. You're saying Newton said this is what you do. You just subtract the momentums, and that's what comes out of the experiment. It's whatever is left over of the subtraction. Whatever the difference going in, it's the difference going out. Okay, and obviously you can't have that difference unless they did exactly the same thing they did when they went in, and you can't do that unless they're the same masses. You can't get out the same thing you put in your physics unless they have the same mass. Otherwise, there has to be a difference. Well, you have to make free kinetic energy. All right, free momentum. It can happen in some cases. So he says capital A, some cases, like an elastic collision with 3-to-1 masses. So again, he's thinking that 3-to-1 is actually the same momentum, same speed, velocity's out, and it's not. That's the 2-to-1 example, when they're both going 1/3 the original velocity. Oh, I didn't read all this extra stuff. Cool. All right, with 3-to-1 mass ratio and equal speeds. Here's what the theory says about momentum. So he's just making this up. So it's not, he's already quoted Huygens and quoted Newton, and I would say quote mind. And, the statement is clear. All you do is subtract. When two objects collide, you subtract the momentums in opposite directions. So there you go. So you're done. So why won't you do this 1 million times 1 million thing and just subtract the opposites? I mean, you're so dishonest. Or sum the momentums in the same direction. So again, where have you dealt with the fact that you just said it? You subtract the momentums in opposite directions. Well, go ahead, apply that rule to the 1 million times 1,050,000 and explain to me what happens when you do the experiment. The value that you get must be the same before and after the collisions, right? So how can you change the before? The before says there's a 50 difference. How can you change that? You can't change that. So your after has to have a 50 difference. You understand? No, you don't understand. Okay, if it's 50 before the collision, it must be 50 after the collision. Right? So you're saying, yes, 100 goes in, 200 comes out, then 200 goes in, and 100 comes out because of direction. And this is also what Newton said very clearly. So that's a big lie. Newton didn't say any of it very clearly. So fuck you, liar. I mean, it's just disgusting to say there was anything clear, okay, in Newton's conversation beyond his clear statement that twice the force, twice the momentum, 3 times the force, 3 times the momentum. Besides that very clear statement, you liar. Oh, it's just disgusting how they can sit there and just, rewrite history. 100 years of controversy, and they're just pretending it didn't exist. 100 years of it. All right, in Ian Gosling's late video, you can see everything you need to see. So we've seen Ian Gosling's videos, and we can see that every single one of them is flawed. Every single one of them he has manipulated or cheated in some way. He has forgotten, or he has, oops, I measured, oops, I did, oops, I forgot about, oops, I didn't do that. Something. All right, he's engineered an outcome and videotaped it, okay? And yes, we could all do that. We can all sit there with a camera for 6 years and, studying or following a squirrel around, and maybe someday you'll be able to catch the squirrel eating a rabbit. Okay, maybe it happens. If you wait long enough, you can find it. You can force it to happen. Now he has an even better video. Says you. All right, both objects reach roughly the same height. Okay, so again, says you. All right, and roughly is more than enough here because your prediction is so catastrophically wrong. And this is some emoticon of some kind. It's just so typical. So anyway, I responded. As is typical of your troll style, you keep evading the simple question. What is your prediction regarding two objects colliding elastically? Okay, two uneven masses, I probably should have said. One object with 600 momentums, who cares which one is which? And the other was 650, exactly the opposite direction. Is 650 is probably a better way to say that. In exactly the opposite direction. So what do you predict? So, we don't have an answer yet, so I can't give you his answer because we don't have one yet. You can see the glitch in YouTube when I refresh that. It's like it's going to display the page and then it retracts it. And then it says, oh, it's the comment page. You can see that. You're not allowed to see the other pages, but you can see this one. Somebody says, hi, sir. I mean, there's just nothing humans can do. They have to break everything. The bro thing or dude. And then have some opposite extreme where somebody says, hi, sir. Who would you say that to on this planet? We're not living back in some day when you had to salute the nobles or something. This whole Surrey thing. It just, ew. There's no sirs you're obligated to say sir to. Oh, God damn it. Anyway. So yes, we'll go find Ian's newest video, and I'll, so he did fix the obvious. This is stuff, I didn't play it, the volume on, so I don't know if he acknowledges the fact that I was absolutely 100% correct, that his experiment works a lot better because he separated the two objects. Okay. I mean, he does have to be informed of because he makes so many mistakes. And so, so it's just a fact. It's not my fault. And then the commenters make up this crap like somehow I'm accusing you of putting magnets in it or doing that. No, they don't make mistakes like that. They make obvious measurement errors. And he did it again in this video. And you're just saying, how many times are you going to keep doing this? He hasn't even weighed the fucking things, right? He's approximating their weight. Oh, shit. All right, so, so I'll go find that. All right, so now I had suggested filming it in the center. He still wouldn't do it. Okay, so he's still off center. Now he does have the proper separation. So now you can see the two of them hang straight down and they're barely touching. They're still touching more than they probably should, frankly, but regardless. Now the problem now is he does, he can't pay any attention. So 3 videos ago I pointed out how you have to do this center of mass thing correctly, and he hasn't done it again. And it's kind of obvious. His own commenters brought it up, 2 weeks ago. Hey, that one's lower than the other one. It can't be lower. That's like the lever thing. You're essentially making it weigh less. The shorter its string is, the less it weighs, essentially. It goes further with less velocity, okay? So, you get the illusion, all right, of more energy because a slower velocity looks like a faster velocity, right? So if I'm on this little arc up here, a pretty slow velocity will look the same as this big velocity down here. So I can have a really slow velocity and it'll look like a bigger velocity. So he clearly hasn't got the center of mass right, which makes all of these lines useless because, frankly, you're supposed to be doing it from the center of mass, not the bottom of one of the objects. So, I mean, these are obvious details, right? I mean, yeah, it's just this futility of this. This is all they need. They're poof. You poofed it again. Okay. So obviously the two objects are of different size. So again, he hasn't confirmed that this is 3-to-1. He's just guesstimating. All right. And he's taken this thing that I claim is certainly lighter, and he's now lifted it higher. So instead of having the center of mass go through both objects equally, right? That's your center line. That's the line you want to measure from. So the first, he's already making the mistake where he's measuring the bottom as the distance. You now go a distance and then you go 4 times that distance. Well, the problem with that is their distance has this extra bit in it you don't want in the measurement. You're gonna multiply that error by 4 over here. So you're going to be adding 4 pieces of wrong here, which means this isn't really half anymore. Okay, so half is someplace over here because now you've drawn it in the wrong place because you've put this extra wrong. Isn't that line 4? Yeah, okay, it's over there. Yeah, see, I drew the 4 over there. Yeah, sorry, where you couldn't see it. It's part of my master plan. All right, so he hasn't got the center of mass correct. All right, so the first rule is you definitely have to get this right. Okay, so the two objects have to be cut by the same line right dead through the center. All right, that alignment has to be correct. And then you use that line, that distance from the ground, let's say. I told him how to do this, right? I said make a little block that's that height. And then you can just add a block for 1 unit of distance, and then just add, your standard block, okay, and then 4 of these blocks, 4 of these distances, and then at least you'll have your heights correct. All right. Now, so what you can see in this experiment is, yes, it appears, okay, that the objects are going similar velocities because they travel the similar distance in the same time. So that seems like the same velocity, right? So I would argue that it's behaving like it's obviously a 2-to-1 relationship where 1/3, okay, the velocity over here, and 1/3 the velocity over here. And because this is a double mass, you multiply that by 2. So you have 2/3 the momentum over here and 1/3 over here. But the velocities, okay, work out the other way. So the idea is that in the 2-to-1 relationship, 1 mass to 2 mass, okay, 66% of the momentum's going this way, 33% of the momentum's going that way. And it looks like the same speed. And then in the 3-to-1, then it's 50% and 50%, okay, of the momentum. So it won't be traveling the same speed in the 3-to-1 relationship. So the idea is that the more reflection you're getting, the less energy goes into the object. That sort of makes sense. I mean, I've made this example 100 times now. But if I had a board and I was whacking tennis balls at it, and I make the board wobbly, flexible, the tennis balls bounce back less aggressively. And the more, if I put the board on wheels, so now the board can actually roll away, now the tennis balls come back with even weaker reflections. So, the more this yields, the less reflection I'm going to get. And that's the truth of it. All right. And obviously it yields a lot when it weighs the same mass. When it weighs a little bit more, it yields a little less, and that means you get some reflection. Then make it even heavier, and it yields even less, and then I get even more reflection. Then I'll get, with a 4 mass, then I'll get 1/3 this way and 2/3 this way. And with a 5 mass, I'll get 0 this way and 100% that way. That's the argument anyway. Alright, so really these drawings was never very good, but this one's even the worst of the bunch, frankly. I mean, it isn't centered, this line isn't even centered to the objects when they're dangling. So we still can't get a fair angle to videotape this from. And, this, why won't that turn on? Took some work. And then he left out this whole other side of the, which would have made this easier to see, is if you saw the whole rest of this arc. And so the trick is, okay, so number one, the weight's too high. So it's traveling a different arc because it's a different height. All right, so the arc for the 2 mass is different. Then, on top of that, you have to acknowledge, oh, wait a minute, if I'm going to draw these arcs, then you have to recognize this is a little bit, it has a correlate to the double slit and the way they confuse that simple subject by not understanding that each slit is its own separate experiment. And in this case, each one of these pendulums, because now that you have separated their distance, right? So now that you have, I'll make this one the bigger one just for the fun. Because you have created this separation of distance, these two have a different circle bottom. And so you have to acknowledge that it's a little different for each one where the circle will be. A little different. Just a fact. The circles are different for the two objects. It's not the same circle anymore. I'll get the hang of this drawing thing eventually, I think. Or not. The frame rate's really terrible on this camera still, but at least it's good enough for drawing. So, I gotta figure out what that is. Anyway, so another flaw. But yes, he hasn't, he doesn't have the heights right because he hasn't paid any attention to the center of mass. He doesn't have the weights right because he didn't measure the weights first. And second, he doesn't have them the same height. The center of mass for the two weights isn't in the same location. So clearly big mistakes. All right, so now we'll just play it and you get, yes, it has the illusion of, hey, look, way too much, 100, a big pile of momentum's going that way and only a little bit's going, blah, blah. It has the look. But if you understand that the 2-to-1 mass ratio experiment would look just like this. So if it was a 1 mass to a 2 mass, this is pretty much exactly how it should look. But this isn't how it should look if it's a 3 mass. All right. Oh, I guess this is where he was doing some sort of, hey guys, look, I did it again. I did some more, stuff. Or maybe he made up some crap about how, oh yeah, well, Gary was absolutely 100% right that I was kind of a stupid idiot for not recognizing these strings should be straight line parallel. They should be perpendicular to the circumference. A bad bit of focus, but that was lucky that didn't last. So he's still, he's letting go with his stick. Like, that's different than letting go with his finger. It really doesn't make a difference. But whatever. We don't need that precision because we can see it go through more than one cycle. So it doesn't matter that his hand gets out of the way by the second version of the experiment. All right, you can see this, right? No, you can't. That's good, I checked. Alright, so he has dropped them. And now we will do the frame by frame shit. Hopefully. I've got to go over here, click on this. Then we should be able to do the frame by frame shit. There we go. Alright, so they're coming together now. Oh, they hit. Okay. So now they're coming apart. So the light mass crashed into the heavier mass, the 2 mass. Alright, and this is what you would expect if it was a 2 mass. So if the mass ratio was 1 to 2, you would expect 1/3 the velocity and 1/3 the velocity in the other direction. So that would be something probably worth counting frames for, is to see if it's 1/3 the velocity. Because his half lines really don't mean anything. Okay. And obviously the heavier mass in this case has gone further than the first mass, meaning it has more velocity, a little bit more velocity. But it really doesn't. It's just that because he didn't account for the fact that there's 2 separate arcs, okay, that they're not on the same arc because they started a 1/2 inch apart, so they have different arcs. That's what's creating that error, that lack of symmetry. That appearance that it has more energy. It's not a reality, just an appearance. Okay, and they come together and you get your full energy back. So this is the collision. This is you could say a 500 momentums and 550 coming into each other. In this case, the heavier object comes in with 550. The lighter object just has the 500. They hit, and all that pops out is the 50. In this case, they're claiming it's 150 and 50. Now, obviously, because he doesn't have the masses right, it's only 33% and 33%, extra the other way. So we get almost back to whatever. Okay, 1/2 inch, but he started above that peg. He's now below the peg. So the experiment is losing a little energy. Now, it might be losing some because he doesn't have them hitting on their centers. So he's losing some momentum to the fact that when the 2 balls hit, one of them's hitting low on the other one, so it's probably popping it up. And so it's not the kind of energy that turns into linear motion. He's turning it into wobble this way instead of linear motion that way. And so that's probably the reason why that's happening. Alright, so this is basically the experiment done over again. So that was like 2 frames, 3, 4, 5, 6, 7, 9, 10. And so now we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, that's how it comes out. Just because of the rules of pendulums. In this case, anyway. So that doesn't sound very helpful. And certainly not half the distance. So if you took the curve line, you could recognize that the curve line certainly isn't the same distance. The length of this line is clearly longer than the length of this line. So doing it in the same number of frames wouldn't be 50-50. It would be something less than 50% the speed. So it's something less than half the speed, half the velocity. All right, how much less? But obviously, theoretically, there's just no wiggle room here. So I can't understand what they're defending. Because they can't really defend that levers don't conserve momentum, and they can't defend that Newton believed you could make free momentum but never wrote about it. So he wrote how there's no such thing as perpetual motion, and yet he believed in free momentum. And I mean, that doesn't make any sense at all. How could he? Again, my first reaction was to say, shit, I'm going to patent this. If you're right, if you people actually are right, I want the patent. Because this is free energy. All right. And obviously you destroy the free energy, but frankly, I can keep making it rather than destroying it. So I'll keep doing the free making it part. Anyway, so I don't know if we need to see much else. So obviously these flaws here. So he's got this line drawn to the bottom of the objects, and it should be to the center of mass. And it shouldn't be to the center of mass of one of them. Both of them should have exactly the same center of mass. And again, you're still stuck with the two arcs being a little bit different because there is a separation between the two bottoms. For each pendulum has a different real bottom. Each one has a different real bottom. So that's all the crap he ignored and didn't pay any attention to. So the Falwell guy says next he'll be claiming you have super strong magnets. So again, I haven't made any claims like that. And as it was true in my last video where I was 100% correct about how he could fix the poor oscillation he had in the experiment, I was absolutely correct. Let's understand. So Walker says, perfect. He didn't measure the mass of the objects, and so it's a perfect experiment, even though he never measured the mass of the objects. It's perfect! So even though he didn't measure the mass, he didn't weigh them, it's perfect. Okay. So Disbar says, brilliant. It can't be more clear than this. So they could actually see in the previous video that the one object was lower than the other one. I didn't have to explain that. They actually brought it up in the comment section. But somehow they don't see it in this video for some reason. For some reason, because this one's less ambiguous, and is on their side. The other one was kind of, it didn't turn out too well. So they were willing to see the problems. But when it turns out to look like what they're saying, well, then there's no problems. So obviously I would argue that this is a 2-to-1 experiment, not a 1-to-3 experiment. So he's called it 1-to-3, even though he didn't weigh the masses. Okay. He's just assuming they're the same steel. Yeah, it has the same density. And, and even with that assumption, he conceded one of the 3 mass is something less than 3. So by 5%, let's say. I'm trying to remember the numbers. 1,500, 500 to 1,500 would be, that would be 1/3. No, it's 500 to 15,000. Yeah, so that would be 5%, less than 5%. Well, I think it's more than that, and frankly, he has it higher, which means he's essentially made it way less. And you're not supposed to do that. All right. So I think that's enough, right? I think I've touched on all the important ones to mention, and so we'll move along. I think that's it. All right, so till the next time and such. They really, I still can't believe that they really are this comfortable defending the idea that I can hit a small thing into a big thing, and I can increase the momentum. And then I can hit that big thing into a bigger thing and increase the momentum. And then hit that thing into a bigger thing and increase the momentum. And they don't see any problem with that. I just don't understand how they can think momentum doesn't mean anything. When, it's the whole mouse elephant, right? I can have a mouse. Okay, a mouse, let's say, weighs 1,000 times less than an elephant. We know it's more than that, right? There's more than 1,000 mouses in an elephant. But it's the same kind of thing, right? I mean, I can have a mouse going 1,000 miles an hour hit you, or I could have an elephant going 1 mile an hour hit you. And guess what? You're going to get squished. Same amount of capacity to smush atoms. You just have to keep doing this. Shit. This is such a dumb planet. Full of liars and cheaters, by the way. It wouldn't be so bad if this was all just ignorance, but it's belligerent ignorance and shenanigans and deception. They're forcing, the evidence. They're not following the evidence. All right. So, till the next time, and such, and so forth, and whatnot.